OK，今天是希望 question. First thing first, you guys must know the difference between fission and fusion. So just based on the English alone, fission means combine together. Oh, sorry. I was confused. Fusion means split, not combine. Combine is the other one. So fusion means split. Fusion means combine. Okay, this is the English meaning. Now, if I just look at this case, this example here, since you ignore all your writing, just look at this. What do you think? Is this fusion or fission?
It's future.
Oh, it says that, did it? Oh, okay, it did. But anyway, even without looking at the question, you should realize it because basically my atom uranium is split into these two. Okay, but of course there are other products as well. That is the main story. So this is fission. Right, what's the nuclide in the nuclear fuel? Now, what's the main nuclide? Oh, nuclide is, I hope you guys know your English. This is the plural for nucleus. Well, unfortunately, it's part of English. Now, what is the nuclide of interest? Which is the fuel? Fuel must be whatever's on the left-hand side, right? Just like combustion, your fuel is on the left-hand side, and the main fuel will be uranium-235. Okay, I can write like this, but of course you can write the full symbol, okay, with the numbers as it is. You can do that too. It's perfectly fine. But for me, oh, okay, not just for me, but for anyone, you can also write uranium-235. Quick question, what does the 235 refer to? Is the
Mass.
Yeah, the mass number. Proton number is fixed at 92. Anything that has 92 protons is uranium, so I do not need to include here. Once I use uranium, automatically it has 92 protons. Now, how about this subatomic particle? Okay, guys, unfortunately, they seldom mention this, but as I said, this is the first year you're tested on radioactivity. What is meant by subatomic particles? Zayden, you need to know this too.
Neutron.
Yes, good. Neutron, proton, and electron, even though there are others. You got to know the meaning subatomic particle.
What's part the take root and extreme property?
Because you assume you know it from chemistry or somewhere else.
But subatomic.
Okay, guys, I want you to write the mass number and proton number for these three particles. They have numbers too. Proton, can you remember? No, the mass number.
Oh. Oh.
4.
I don't know. That's different. Sorry.
Okay, how about electron? What's the mass number?
Wait, one and electron is the 1/1840.
No, don't confuse that. That's the relative mass. But here, if you want to write the mass number as 0, normally they don't write the fraction. Not in this format. Charge -1. Okay, fair enough. Because it's the opposite of a proton, so it's -1 here. Proton? What's the mass number? What's the relative mass of proton? Yes, 1. What's the charge of proton? Yes, +1. But normally they don't put the plus there because it's understood. Now, neutron is what we seldom discuss. Mass number, good. Charge, good. Can't remember. Okay, remember this three. So I think you know the answer by now. This is your subatomic particle that hits your fuel.
Oh, one.
So it's neutron. Okay. So this is the one that bombards your fuel, which is uranium. Okay, guys, I want to introduce this word to you because at first I'm not too sure whether your textbook include these words, but apparently it does. Whatever's on the left-hand side, this guy here is called, there's an alternative name for that, it's called parents. Now, whatever's on the right-hand side, the atoms, not subatomic particles, but the atoms are called daughters. There are no sons. There's only parent and daughter and granddaughter.
What equals?
Good question. Not sure.
What?
So unfortunately, you need to know this because you notice they use the word daughter. So your daughter nuclei, in this case, Jinjie is correct. Barium and krypton. Subatomic particles and radiation release. Again, Jinjie is correct. Neutron is a subatomic particle. Excuse me. Radiation is gamma.
Right.
No need. Oh, I hope both of you can recognize the symbol gamma. Unfortunately, they recognize Zayden. Okay, gamma. Energy store from which energy is released. Energy store. There are a few possible answers, but I'll call it nuclear store.
What is? Oh, nuclear energy.
Yeah, nuclear energy. Okay. Energy store of the fission fragments. Fission fragments. These are all the fission fragments. I'm not exactly sure what they're asking for though.
Yes, exactly.
Yeah. Energy transfer through the gamma radiation. This one again, I'm not exactly sure what answer they want. Fusion. Oh, by the way, these are all fusion fragments, but really distinct. Could be, but I better double check on this fusion fragments. Okay, for now, let's put it as heat first. I need to double check. Or thermal energy. Thermal store.
It was again.
No, they won't. They should not. Yeah, but now they like to use the word store. Everything is store. That means you have this pool of energy. Is it kinetic pool, kinetic store, potential store? energy transfer through the, I'm not exactly gamma radiation. This one I need to double check now, but what do you think, Jing? Gamma radiation, energy transfer. Okay, at this point, I just put it as electromagnetic waves.
And
Hmm?
that's energy.
Okay, remember what is waves? What do waves do?
Transfer energy.
Yeah, they transfer energy, right? Without transferring matter. So, okay, I put it as electromagnetic waves. So that is how energy is transferred via electromagnetic waves. Yeah. But this I'm not too sure. Energy stores. I suspect it's heat. It cannot be other answers, right? Any other energy? Potential, maybe potential, but I doubt so. Kinetic could be. No, light. Light is in the form of gamma already. Could be kinetic, no? Let me fusion fragments. Because they could be moving very fast. Could be kinetic store as well. So I put it as heat store or kinetic store. But I'll check out on this as well. Okay, let's look at the next one. Can be very useful if some neutrons are removed from the products. What does it mean? Okay, the one that answer that comes to my mind. Look at here. I hope you notice something. Electrons on the right, electron on the left. Right. So what does it mean? It means that this electron can hit another uranium. Oh, sorry, neutron. Yeah, right. I was thinking of something. So this one of these neutrons can hit a uranium, and then the cycle repeats. It as it impacts, collides. They are all moving very fast. But what does that mean? It means this process will keep on going and going and going, right? As long as you have uranium left, it keeps on going and going. It's self-sustaining. So the answer that comes to my mind, basically it means the process can be controlled. Controlled. Because you don't want the process to keep on going forever, no? You want to control the process. Yeah, that's the thing. I mean, this is the first time coming out, so I don't even know what questions are going to come out. Can be controlled by limiting the number of neutrons. Colliding with uranium-235. Again, reminder, uranium-235 is the fuel. Not this part. Because the thing I thought was more about the using radioactivity for the measuring thickness, for X-ray, not so much for energy generation.
Text to me for only 2 pages.
Really? Okay, come this one again. make sure you know this is fusion. Two of them combine together to become a big atom. Okay, so make sure you can differentiate that, even though it's written here. So what's the nuclear fuel? Yes, both of them. Helium, not helium, hydrogen 2 and hydrogen 3. How are they brought together? Wow. Think about it. You force them together into one atom. How to do that? You need very high temperature, very high temperature. Okay, not just ordinarily high, but very high. You're talking about like many of thousands degrees Celsius. Daughter nuclei form if essentially there's only one. Helium-4. Because neutron, take note, neutron is not considered a nuclei, it's not considered a nucleus. By itself, it's not. Subatomic particles? Yeah, a good old friend, neutron. Plus gamma. Energy store from which energy is released, nuclear storm. Just a note. Let me go back to the first question because I now realize something. You notice there's an energy here. What energy is this?
Oh, hard. Nuclear energy. Yeah.
Not exactly. This one is heat. You want to harness that heat. So come, guys, both of you, right now. That energy is heat. This one, heat.
So every of these equations, the energy will be.
Yeah. But notice they separate gamma and heat. Okay, so gamma is not considered heat. Therefore, therefore, I'm thinking about this question. Energy stored of fusion fragments. I think a better answer would be kinetic rather than heat, because heat is already separated. Then I suppose your school also mentioned the word store before.
They all change those store now.
Yeah.
Like energy and kinetic.
Okay, so you just keep that in mind. Okay, can. But anyway, I still check out on some of the answers, especially the nuke fusion fragments one. Okay, yeah, hopefully that answers that. Now for today, I intend to go through waves. Why? Your favorite? So all the more you should go through.
But no.
I mean, just write something. I won't be writing too much, just a bit only, because you should know most of the stuff already. You should. Okay, come Zayden, give me one formula for waves. Okay, that one is standard. Oh, where are you going? Yeah. Okay. Zayden, what is meant by V?
V is the speed.
Good. Units.
Meter per second.
Good. F is
Frequency.
units.
Hertz.
Good. This.
Wavelength.
Good. Units. Wavelength. Length is in meters. Be careful because they can give you nanometers, micrometers. Make sure you convert. Another formula. Good. What is T? Good. Units. Period is what's meant by period anyway? Okay. Okay. The time for one wave to pass through a certain point. So time means it must be measured in time. Time.
Oh my God.
Time is just seconds. Now, as I said before, the third formula is your primary school formula. Okay, so this is speed, distance, and of course time. Again, check all the units.
Can I include echo?
Include what?
Echo.
Echo will be under sound. But I think I have some questions. I don't know whether got echo. But echo should be quite simple, right? Never mind. I give you some sound questions very soon. Now, what is the other thing you got to be careful of? Now, let's say I have a graph. Confirm coming out and confirm. And then they should confirm show you something like this. Come, what's the y-axis?
Displacement distance.
Usually it's displacement, usually, but not always. Because if there's sound, this one can be pressure. That one is difficult. This is the important part. Both of you, check this. If this is time, what can the graph tell you? Time. Or let me circle it.
Frequency.
No, not yet. What does this tell you? To be more exact, what does this tell you? This is the period. So watch out. If this is time, this is period. It can only tell you period. Only then you work up your frequency. Okay? Can this graph tell you wavelength and speed? Answer is no. You need extra info to find it. Okay, make sure you realize that this graph cannot tell you wavelength and speed. You need other info, not just this graph. So remember that. Remember that it's quite common to see mistakes over here. But what's the other graph? What against what? Okay. Well, this is possibly displacement against distance. The curve can look exactly the same. But the difficult part is if I go and highlight this one cycle, what does this tell you? Yeah, because this is distance. Okay, so don't take note to this. Definitely can come up for you. This is one wavelength. And make sure you understand this graph cannot tell you frequency and speed. You need other info. Now, one more thing that you may need to use in your answer Huh? What is this called? This
Why the X in this?
I mean, likewise for here as well. Can you remember, Zayden? So make sure you use the correct term. This is called the equilibrium position.
Ah. Oh.
Should have. But of course, I didn't emphasize too much on this because I think at that time only you and Fuqin were here, and you know how distracted he was.
Press P.
Now, likewise, you better know what is this maximum point. Yeah, Jinjie, you said it just now.
Oh. Press is up.
That is the crest.
The maximum.
They may they may still mark you correct lah. They may. They may. They may. Come, Zayden, what's the opposite of the crest? This one here.
Opposite crest is
Yeah. Now, both of you need to know, it's called trough. Some quick question. Can you all remember what is amplitude? Maximum to? Maximum to? Minimum? No. Yes. So technically it's from the crest to the equilibrium position. That is your amplitude. But there's another, there's an alternative. It is also from the minimum or from the trough to the equilibrium point. So that is also counted as amplitude. Make sure you realize that too.
This water amplitude.
Yes, either top or bottom, but not.
But will it be equal?
Yeah, they should be equal. Oh, okay. Depends. If your question is difficult, let's say the wave, realize the wave can change in amplitude. Over time, become bigger and bigger, then they may not be equal. Okay, so just keep that in mind. Look at the question carefully. I expect those kind of questions to be quite difficult. When they change in amplitude, becomes smaller and smaller and smaller and smaller. So the amplitude can change. Okay.
But if it becomes smaller, in the frequency is higher. Every time.
Okay, both of you take note. Frequency normally does not change. Normally, or based on your syllabus, it does not change. But in real life, it can change, but we won't go into that. Yep, those are the basics. Any questions? But sound is difficult. I totally agree. When they include pressure inside, wow, that one can cry. And they include compression and reflection. But give up. Okay, go guys. Some basic questions for you. Only MCQs. Better don't tell me you get stuck in question one, huh?
这跟思想怎么说
For your syllabus, no.
啊？说的好难听。
Okay, which question now? Number 2, right? Okay, the trick is this. For your syllabus, frequency doesn't change. But what changes? Wavelength and yes, the other two must change.
What's the definition?
Definition of
MP.
MCQ. Okay. Which question is that? Show you one. This one. This one. This one. So it continues and continues and continues. Because this one is still radioactive. It will break down. This one is still radioactive. It breaks down again.
Twice.
Neutron. Give me a moment. Let me just fix this. 7, right? You said
6.
6. What do you think? Is from the top to the middle or from the bottom to the middle? So that would be the maximum displacement. Whether top or bottom is still the maximum.
Well, wavelengths in 12 meters high.
But you don't know how long is the wavelength, no? Okay. They ask for frequency. All right, so what are the formulas for frequency? F equals to 1 over T, or the other one, F equals to V over lambda. All right. But do you know the speed? Not exactly, it's not obvious. But do you know the period? 12. No, 1 minute has 12 wavelengths. Okay, so I write up like this using a primary school math. So 12 wavelengths is equivalent to 1 minute. Tell me, one wavelength is how many minutes?
5. No, 5.
Yes, 5 seconds. Good. And since this is time, one wavelength takes 5 seconds. Automatically, this tells you the period. Okay, so you do know the period. Okay, just keep these formulas in your head and then look what information you have. Okay, oh, remember, at the end of the day, you only have 3 formulas dealing with waves. You won't have electricity combined with waves. You probably won't have heat combined with waves. So it's rather standalone. But doesn't mean it's easier. The only thing they can combine with heat can combine with waves is through infrared. But so far, I haven't seen that kind of question yet. You never know. They can come with all sorts of creative questions. Somehow there's a big unknown chapter this year. I mean, nobody knows what kind of questions you come up for radioactivity.
But they don't be too crazy.
Hopefully not, sir.
Sure. For question 11, the wavelength is 12 cm.
Question 11. Okay. 1.2 cm. Tinkin, you may want to look at 11. This is 1.2, not 12. Okay. So remember, frequency does not change, but wavelength and speed do. And by the way, guys, for question 11, can you also add in, this is, what is this process called? you have this waves moving here, suddenly it goes here. What's this process called? You should know the name.
Propagation.
Propagation means moving, but here there is a bending. Bending means there is, guys, right now, this is refraction. So water waves can undergo refraction too because there's a change in speed. It's not just like waves.
Have you said waves can go through refraction?
Waves can what?
Waves can go through refraction.
No, I didn't mention it, but well, you learn along the way.
And stuff.
But anyway, actually the word is there. I don't even need to mention the word is there, refraction. Yeah, but at least you get your basics, your foundation stronger. I mean, these are all like small details. Make sure the basic formulas are you already have a good understanding of them. How to chop.
They only give frequency.
20 hertz. Point P at center of a compression. How much time elapses before the next reflection? Okay, the point is this. Sound wave, come, Jingjie, you get your wish. This is sound wave 12. Jaden can remember for sound wave. How does it sound wave? So let me, if I draw this up like that, so this is against time or distance. Okay, let's say distance. This is displacement. This is a distance. So you will have something like this. Now, at where is the reflection? Let me see. Compression means reflection. Okay, essentially, maximum displacement. Oh, this one not so easy. Let me think carefully. This is displaced to the right. That is displaced to the left. Oh, this one is difficult. It's tough for me right now.
You need to draw like.
No need to draw. No need to draw. Actually, I don't even need this graph. It's just extra info, but it can come up. But never mind. Come. Just remember something. Sound wave. Compression followed by rarefaction, followed by compression, rarefaction, alternate. So the distance between two rarefaction is the wavelength.
Two reflection.
Oh, sorry, two compressions.
Yeah.
But it doesn't matter. The distance between two rarefactions is also the wavelength. But here, here they're asking about compression and rarefaction, so it's half a wavelength. I think you can tell that. This is half a wavelength. Right. Distance between one rarefaction and one compression is half a wavelength. But there's a small problem. It's the question about wavelength.
No.
It's not. So this does not apply. However, you can look at it another way. This is based on what distance? Right? But if I redraw this, and this is based on time, what is the time between one compression and the next compression? That means, let's say at this point, compression now, right? Compression. Then when does the next compression come in? What time? No, you don't know, but that is the period. 1 period. After 1 period, the next compression will occur.
So they are asking about the period.
We are not done yet, but they're asking about the time between compression and rarefaction is half a period. Okay, so look at 20 hertz. Come, how to make use of 20 hertz? Good. So you can find period.
Oh, that's one. Oh,
You know the period? And basically the next rarefaction occurs in half the period. So half the period is 0.025 seconds. That's the difficult part. Because sound includes compression and rarefactions. I haven't shown you the difficult questions yet for sound. Because so far, I think there's no pressure question inside yet. It's quite messed up. It's quite messed up, but never mind, as I said, get the basics right. Actually, sound wave should be the worst. Sound wave.
teacher, when you hear questions, you see the water will go from like don't know where all the way on top. Like
16,
yeah. The frequency doesn't change, right?
Let me double check first. Wavelength is different when it passes over the glass block. Good. Yes, it doesn't.
But does the speed increase?
Oh, this one you must be able to answer. Now, look at your formula. E equals to F lambda. Now, if let's say my F is constant, frequency doesn't change, shows that the wavelength is different when it passes over the glass. Now, wavelength, what happens to the wavelength? Do you notice? Look carefully. This is one wavelength. This is also one wavelength. What happened? What has happened to the wavelength? Increase or decrease?
Decrease.
Good. So since wavelength decreases, what will happen to the speed? Yes, because frequency is constant. If this decreases, speed decreases too. Now, I know it's a bit tricky, but it's not that difficult. But for both of you, remember frequency doesn't change for your syllabus. Unless the question somehow tells you otherwise. Only that doesn't come up. Oh, 17, okay, right. No. Yeah, that's the best way to do it. But of course, in the exam, you must have the time to do it now. So I fixed 2 points, P and Q. But I have a computer, so I can do it easily. So initially, the points are like that. P and Q. So this is equilibrium. This is max. Okay. And then this is like that. If you have color pencils, of course, you can do it easily. Sorry. Let me redraw. So this is max. This is equilibrium. Here is like that. Here is like that. All right. So it's moving from left to right. Half a cycle means what? Half cycle means half a wave, right? So from here, what happens is, you notice, moving to the right half, Okay, so it has moved half a wave already. This is half a wave. So where is Q now? Q is now at the bottom, at the trough. T is now at the equilibrium. So you notice half a wave has passed. I hope you can tell. Let me highlight it. So this is half a wave. Okay, half a wave has passed point Q. And of course, half a wave has passed point P as well. So what happened? Point Q by right now it has at the trough. Point P is now at equilibrium.
Same level as
I mean, these two dots are just markers for the position. It doesn't indicate that they are always at the same level.
Oh,
Mm.
so in one question. Equal. Yeah, but not easy lah. That means you have to draw and then probably use a string or something, then pull it across, or use a curve rule. Use a curve rule. Since you can't bring curve rule for exam, kind of. Oh, you say that you need to draw a graph, so you draw a curve rule along. Use a curve rule to make that wave. Then move from left to right. What? I'm going to try that.
President can follow. This is the original one, right? Correct, original. So it moves from left to right. Now, half a wave has passed. So where is Q? Q is now at the bottom. P is at the equilibrium. Yeah.
What does it rise?
It rises again because you continue moving. Then eventually your Q will go back to the max again because your wave is moving from left to right. Eventually it will.
What can you move forward and rise?
Yeah, basically from the top, go down, bottom, up, down, up, down, up, down, as the wave passes them. P also the same. Yeah, I mean, but of course they don't move up at the same time. They move at different times, something like that. Why that? You mean what's the answer? Okay, so we'll go back to the original position now. Original is like that, right? So what happens to your Q? Q is the first here.
Yeah.
It falls all the way to the bottom. So Q falls. So it's either A or B. What about P? P, what happened? Fall, rise. So P actually falls and then rises back up. Okay, so of course, answer will be. It should have, but I haven't tried looking for that. Maybe there is. Let me see. I think there is, but may not be what you want though. How do I even get it to start? No. I thought it's nothing, but I can't see anything. Yeah, nothing at all, right? Maybe my laptop is not, doesn't have the driver for that. This one you can't see. This is the top view. This is not side view. Try to install it. Okay, it's the same thing. It's the same thing.
I try.
It should be running now, but I don't see anything though. Yeah, you try. Maybe I suspect it could be my computer.
What's it called? waves.
Yeah, fat wave simulator. Oh, can already. But it can't still explain what is happening. No? Let's just put one shot. Let's put more drop. So we just go up, down, down, same thing here. Up, down, up, down. I increase the amplitude of max a bit. So at any point, the water molecule is going up, down, up, down, up, down.
The object.
Okay. So at any point, it's up, down, up, down, up, down, up, while the wave move from left to right. Does it even help? Because I thought my one was quite okay, but of course not everyone can accept this one. You know that at first it's like that. The position is here. So what happens next? The position becomes lower, lower, lower. I mean, I'm looking at this point Q only. I'm only interested in the point Q. Okay, come, I draw a line across, or a line down. So if I draw a straight vertical line down, position Q, if I fix it, I lock out this line. So at first it was like that. But the wave moved from left to right. So now what happens next? Now it's moving down, down, down. It's now here, down. Now it's an equilibrium position. Okay, then the point Q continue moving down, 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 until it's at the trunk. That's what I'm trying to say. This, to me, this is the best way to visualize it, but it may not work for you. You need help? Zayden can follow this one. But this is usually the toughest question. I mean, for wait, don't talk about sound first. But this one can, right? The model I have here, this one.
Drop one. Then P will
Drop and then rise again.
So it will drop. Then for Q it will drop.
All the way to the bottom.
And then it will start rising.
Yeah, but that is beyond the question already. So same thing, let me just color P. I draw a straight vertical line down. Okay, so look carefully what happens to your P. So at first, I'm just talking about P and Q. So at first, P is here. Then what happens? Move down, right? Now P is lower already, right?
Then Q
lower. Yeah, but of course, like I told him, I'm just looking at P right now. And P continue moving down, moving down. Then what happens next? Now it start to rise P, right? Now it's higher, 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 until P is now back to the equilibrium position. But of course, in the exam, I don't know how you want to replicate that. Use your curve rule and move from left to right. But you have to, your scale must be correct. High chance. Comes out almost every year. High chance. Even for Zayden as well. They like this question.
So where's the amplitude on the screen?
Amplitude. Oh, let me see. Question. This one is difficult because this is not transverse wave, this is a longitudinal wave. Therefore, once you have a longitudinal wave, you have compression and rarefaction. Always remember that. Zayden, can you tell where is the compression in the type? Yes, good. Since you better be able to tell, this is a compression.
Yeah.
And this is a compression too.
Yeah.
So the distance between two compression will be the wavelength. Okay, so this is the wavelength. That one should be easy. So, but we are not done. It moves between two positions that are 1 cm apart. The point, let me see, where's the point? Did they mention the point? No, right? No, they didn't say where. So, look at it this way. Okay, I don't even look at the screen. I have this point. It moves to the right. Then it moves back to the left. Then it moves back to the equilibrium. Can follow. Now, what is the distance? 1 cm, right? But where is the amplitude? Amplitude is between equilibrium and maximum displacement. Can both of you make sure recognize this is amplitude? Yes, it's half cm. Equilibrium to the max is the amplitude. But the other way around is the same as well. On the other side, it's also amplitude. Yes, wavelength is 12, amplitude is 0.5. So A should be the answer. Yeah. Because it's hard to visualize. You don't even want to go into electromagnetic waves now. You think about it. What's the displacement represent? Are the air molecules moving? No. What is moving? That is the big question, right? They didn't mention, right? Yeah, but what is moving? No, never. It's not so much for O levels. But haven't you wonder what does that even mean? What is moving up and down? Is it the air molecules? No. It can go through vacuum. It doesn't need air molecules. So what is moving? Good question, right? There are very few electrons in vacuum. No, it's the electric field strength and magnetic field strength. That's why do you think it's called electromagnetic wave? Because they have electric and magnetic field strength. If you go to uni level, then yes, you learn about this.
I think I'll ask. How the Earth protect us from UV rays? You gonna ask that?
Yeah, because the light has a magnetic field strength, so it will interact with the magnetic field of the Earth, and then they will be electric field and magnetic field. They can interact. Yeah, EMI and of course the other one, even the motor effect. Not to mention radio, no. Even if you next time you go into university or you go out to work like radio engineer, you know how much complexity there is in the radio. What? Complexity in a radio. How does a radio work? But don't forget, even your handphone is a radio. It uses radio waves or microwaves. How does your Wi-Fi work? How does your Bluetooth work?
So they all radio.
They are all radio waves, huh? And then there are different types of radio waves. It's not just all radio waves. Different types have different properties. Some can bounce on water, some can bounce in the sky, some cannot bounce.
Wi-Fi can bounce.
Wi-Fi can.
Oh.
You need a longer wavelength to do the bouncing.
What's the longest radio wave?
Wow. I think the wavelength is about kilometer long. Imagine a wavelength is a few kilometers long. That is one wavelength. But that one can travel very, very far.
Is that the space?
Yeah. But they also do it on Earth. That means you send all the way to halfway around the world.
Oh.
Or perhaps even go underwater.
That's how they find out the creature down there.
Maybe, but they also need communication with like submarines.
Oh.
So that radio wave can go through water.
But oh,
It is, but it depends whether you want to go into science in your future.
but then I think in the future, all the job is only science. Still.
Even then, maybe certain branches of science.
On the AI.
Yeah. But IT will always be in demand, but just that IT changes very fast. Like cyber security, you always need people in cyber security.
Not all have about
Oh God.
what they do, they prevent hack.
Yeah.
Oh.
It's not you join the army or join police.
No.
They need cyber security experts. But you better be good at coding, obviously. No, I mean I do, but I haven't practiced for a long, long time. I don't particularly like it. It sounds so boring. Oh, Zayden, any more questions?
Okay, I need to look at getting to all
Which one?
trees because of
Oh, here, you mean this one, 21.
Yeah,
You better know it.
it's not graceful.
You mean this one?
Yeah. How
1 kilometer is how many meters?
1,000.
Yeah, so you just multiply by 1,000, you get 1,400 meters per second.
Very full.
Same thing, wavelength.
Which is the answer B.
Come, Zayden, what is the wavelength in meters?
I changed to KM.
Oh, you changed to km. Okay, but got to be careful.
It is 7 times 10 to the power -7.
In km.
Yeah.
Yeah, in km, yes. But for me, I normally just change to meters because if possible, stick to SI units. If possible. But anyway, you get your answer? Good. Try not to be careless. And Jing, you better get it correct for 21. You better. You better.
Thanks. Oh.
See that? You're all done already, right?
Yes.
Okay. Jing, I assume you're done as well. Oh, what
yeah.
did you try?
Yes.
Okay.
Pause.
Okay, come. I see how much I can go through. Number 1. Good. You should get it. You better get it. Okay, number 2. You all keep quiet. Assume you all got it. Right. Yes. This one you better get it. 4. Yeah, got it. Okay, I go on. 5. Okay, make sure you answer. You answer this because this is a sound wave, even though they put ultra in front. Okay, this one these two have done. Number 8, come check. Okay, number 9, you better, I mean, this is a repeat actually.
They should do it again.
Okay, number 10.
No.
Each coil completes 4 oscillations in 2 seconds. 4 oscillations means what? 4 cycles, right? 4 cycles in 2 seconds. So what can that tell you, this information? Does it tell you the wavelength? No, it doesn't tell you wavelength. What does it tell you? It tells you the frequency. Come guys, let's. Oh, careless.
Yeah.
Okay, come. Let me finish this off. I can finish the rest next week because I got next class already. Frequency means number of cycles. This is another definition that you need to know. Number of cycles or number of waves in 1 second. Just keep this in mind. So here I have 4 cycles in 2 seconds. So 4 divided by 2, it means the frequency is 2 hertz. Okay, so yeah, that's why I think Y to Z should be okay, right? Y to Z. What's the frequency of the wave? Wavelength Y to Z should be okay, right?
Yeah.
Compression. Okay, come guys, because I got another class coming in. Bring this back next week. Huh? No, another class.
Got the other.
Yeah. Can bring this along next week. You try to get everything right.
One question. Is there one question?
No.
For children, right?
But for what topic?
For
Oh, more. Oh, okay, that's good.
percentage.
So what's the difficult one? What's the difficult? What are those that you got wrong?
Oh. Base condition.
Oh, is it?
It's a comparing. That one I get wrong. Yeah.
Right? Of course, if you need help, bring along. Okay, bye.
Bye-bye.
Bye. Hello, Lucas. No, Angel is not here today. Let me just stop.